Okay, section 2.5 is all about the fundamental theorem of calculus. We're going to start with our linear factorization theorem. If f of x is a polynomial of degree n, where n is greater than 0, so a positive number for our polynomial, then f has exactly n linear factors. So if I have a polynomial of 4th degree, I have 4 factors. Polynomial of 100th degree would be 100 factors. And you would list these factors out just like this, the x minus some number, x minus some number, and so forth, till you get however many factors it should be. The C1, C2, Cn are complex numbers. Do remember that your complex numbers don't necessarily have to be a real number and an imaginary number. Could just be a real number, so you could have x minus 2. Could just be an imaginary number, so you might have x minus 2i. Or it could be the real and imaginary, where you would have the x minus 2 plus 2i, or something like that. State how many zeros each polynomial has, then find the zeros. So on this first one, this is at 1st degree, so it has 1, 0. To find that, I'm going to set this equal to 0. So x minus 2 equals 0, which means x equals 2. Factors, there's really just going to be the one. It's x minus 2. Zeros, again, there's only the one. Oops. There's not an eraser in here, so sorry. It's 2. Your x-intercept, since 2 is a real number, that would be an x-intercept. Okay, and I'm actually going to have you list these on these as well, even though it doesn't say that. Over here on number 2, it's a polynomial of 2nd degree, so that's going to be 2 zeros. When you set that equal to 0, you can solve that. I'd probably do factoring, but you could also do a quadratic formula that factors into x minus 3 and x minus 3, which means I have x minus 3 equals 0, x minus 3 equals 0, so x equals 3, and x equals 3. You do need it written out twice. This is called a multiple root. If I asked you to list out the factors, that'd be x minus 3 and x minus 3. If I asked you to list out the zeros, just like there were 2 factors, because it was a polynomial of 2nd degree, there's going to be 2 zeros, 3 and 3. And then your x-intercepts just can't be more than 2. And that's going to be 3, 0, and 3, 0. Okay, we have some cubics, some quadratics, sorry, not quadratics, some 4th degree polynomials. Same thing. For number 3, it's a 3rd degree, so there's going to be 3 zeros. You're going to set that equal to 0. When you solve that, I'd factor out the x. I'm left with x squared plus 4 equals 0. Set each of those equal to 0. This is going to give me x squared equals negative 4, so x equals plus or minus 2i. When I list out my factors, x, ignore that right there, x minus 2i, and x plus 2i. Your zeros are going to be 0, 2i, and negative 2i. Notice that there are 3 zeros, there are 3 factors, because it's a polynomial of 3rd degree. Your x-intercepts just can't be more than 3, There's actually only 1 at 0, 0. And if you were to look at that graph, this is just going to be a very rough sketch. It's only crossing the x-axis once. That's why there's only one x-intercept. Over here, oh, there's two number 3s. Over here on number 4, this is a 4th degree, so there's going to be 4 zeros. You're going to do just like you've been doing for all the other ones, setting them equal to 0 and factoring. I'm going to go ahead and pause this, and I'll work that out. I'd appreciate you pausing it and trying to do that on your own. I used that was the difference of two squares, and I was able to factor that into x squared plus 1 and x squared minus 1, which gave me plus or minus I and plus or minus negative 1. When I listed out my factors, I had 4 factors, I have 4 zeros, I only have 2 x-intercepts because only 2 of these were real numbers. This one, with it being a polynomial of 5th degree, it will have 5 zeros. It's not going to be where I can just factor it or factor out a common factor for each of them. I can't factor by grouping, so basically no factoring. It's not a quadratic, so I can't do a quadratic formula. I'm going to need to list all of my possible rational roots, which, if you remember, is your factors of your constant divided by factors of your leading coefficient. So when I do that, factors of 8, plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. My leading coefficient's 1, so I'm really just doing that divided by plus or minus 1, which means these are my possible rational roots. I'm going to start checking them to see which one's actually a root or a 0, so I'll plug them in, whichever one gives me 0. If you are using a calculator, so if it's something where I'm letting you use a calculator, you could graph it and look at the graph, but you do need to be able to do it without your graphing calculator. Since I plugged 1 in and did get 0 as my answer, 1 is one of the actual rational roots, so I'm going to use that 1 and do synthetic division. I'm going to change color. So I'll put my 1 in here, in my little box, put all my coefficients out here. Don't forget to leave a spot for your x to the 4th. Go ahead and do your synthetic division. Since I already plugged 1 in up here and I got the answer of 0, I am expecting this remainder of 0, but I still need to do the synthetic division so that I can start breaking down my polynomial, because this will now be x to the 4th plus x cubed plus 2x squared plus 4x minus 8. From there, I need to keep trying my other possible rational roots, and then I'm going to do synthetic division with them. I found out that negative 2 worked. I did my synthetic division with that, got my remainder of 0, which is what I'm looking for, ended up with x cubed minus x squared plus 4x minus 4. I'm still trying to break this down, but now that it's a cubic, I can factor this by grouping. So I look in my first two terms, I can bring out an x squared. I'm left with x minus 1. Second two terms, I can bring out a 4. I'm left with x minus 1, which means x squared plus 4 and x minus 1 are my factors, setting each of those equal to 0. Here I'm going to get plus or minus 2i. Over here, x minus 1 equals 0 is going to give me x equals 1. Now that I have all of my zeros, I do want to make sure we can write these out and we don't lose anything. So first off, just like we did for the other ones, I'm going to list out my factors. Over here, 1 was one of my zeros, so I have x minus 1. Negative 2 was one of my zeros, so I have x plus 2. I have the plus and minus 2i, so x minus 2i, x plus 2i, I have a positive 1, so x minus 1. So my zeros, and here I might try to actually list them out in order. I have this negative 2, I have this 1, I have this plus or minus 2i, I have that 1. So negative 2, 1, 1, 2i, and negative 2i. Since this is a polynomial of 5th degree, make sure you have 5 factors and 5 zeros. The x-intercepts just can't have more than 5, so I'm just going to use my real numbers. My x-intercepts are going to be negative 2, 0, 1, 0, and 1, 0. While 1 is listed twice, it's the same thing. It seems repetitive. You do need to list them both out. It's a multiple root. It's going to be hitting your x-axis and bouncing back off. It is important that you are listing it for every time that it happens. On this one, we're finding a 4th degree polynomial with real coefficients. And negative 1, and 3i are the zeros. First off, it's important to note, to get 3i, that means you did the square root of a negative 9. Whenever you do square root of negative 9, don't forget it's a plus or minus. So if you have a positive 3i, you also have a negative 3i as one of your zeros. To find that polynomial, I'm going to take my zeros and I'm going to use it to write out my factors. Then I'm going to multiply my factors to get my final polynomial. And I'm going to call mine f of x. Go ahead and do that. Okay, I ended up with x to the 4th plus 2x cubed plus 10x squared plus 18x plus 9. Do make sure you write these in the correct order and that you are simplifying. On 7, I'm asking you to factor. So I can treat this like a quadratic, except for that when I factor it, instead of these being x's, they're actually going to be x squareds, since it was x to the 4th and x squared there. I'm going to have x squared minus 5 and x squared plus 4. X squared minus 5, I can break that down, and to help me see what that is, I'm going to use that to find my zeros. So that'd be x squared equals 5. So x is going to be plus or minus the square root of 5. Those are my two zeros, which means this breaks down into the two factors of x minus the square root of 5 on the eraser, and x plus the square root of 5. And no, the order doesn't matter, but I just wanted to list them out in the order that I did them over there. This x squared plus 4, when I set that equal to 0 to find the zeros, I get x squared equals 4. So x is equal to plus or minus 2i. So those factors are going to be x minus 2i and x plus 2i. Those are my 4 factors. You do have 4 zeros as well, which are listed over here. Okay, this is the last problem. Find all zeros for this polynomial. You're going to start just like we did on number 5 by listing your possible rational roots. Take a second, go ahead and do that. Once I have listed my possible rational roots, I can check them by starting to plug them in. When there's this many though, I wouldn't ask you to do that because that would really suck if like negative 60 was the only one that worked and you had to go through all of those. So if you look at your graph, I'm not going to give you an exact graph, but I can tell that it crosses at negative 2 and positive 3. The graph looks something like that. Okay, I apologize if this got chunky sounding or messed up, but I'm about to run out of my maximum time that I can do the recording. I'm going to use my negative 2 and my 3 to do the synthetic division. From there I'll end up with a quadratic that I can do quadratic formula with because it does not factor to get my zeros. I'm going to go ahead and put all the work on there for you, but do try to do it on your own. Pause it and then check it. Sorry I had to go so quickly on that one. Do let me know tomorrow during class if you had any questions on it.